In this video, we will talk about transformation of parent functions. Okay. So what is transformation? It is if you move your parent function up, down, left, right, or make your parent function become wider, thinner, or upside down, this kind of changes on the parent graph. It's called transformation. So how will the transformation happen? If you put numbers in the parent equation, the corresponding picture is going to change, and that kind of change is called transformation. So let's look at the pictures. So here for the black part, it is the parent function y equals x squared. Let's take it as an example. So you see if I move the parent function up, I have this, I call it a baby function. Okay? So the baby function and the parent function have the same shape, but on the different positions. Or if I move the parent function down, I have this baby function. If I move the parent to the left and the right, I will have the corresponding baby functions. You see what? You see the baby function have the same shape as your parent function, but the change is it moves your parent function up, down, left, right. So this kind of movement is called transformation. Or if we have the parent function, which is also the quadratic function, if you're not moving its position, but you make your parent function thinner, like this, or wider, like this, or if you make your parent function upside down, this kind of changes on the parent function is also called transformation. Okay? So today we're going to see what kind of change in the parent equations is going to make the corresponding change or transformation on the parent picture. Okay, so we have 7 types of transformation we're going to deal with, which is move up, down, left, right, or change the parent into wider, thinner, or upside down. So let's look at each of them. So the first example, we're using the parent function y equals x squared as an example. So you'll see the baby function, the baby equation, or the transformed equation, have the most basic part, the parent part, which is x squared. However, we add a number in the equation. And where did we add it? So you can see we add a number inside of x, or we add a number inside of the function square. Okay? So if you add a number inside, let's see what kind of change or transformation is going to happen on the parent graph. So let's graph both of the parent and the baby equation to see the transformation on the graph. Okay? And we're going to graph using the decimals online calculator. Let's put the parent equation and the baby equation in, which is y equals x squared. Square is down here. And then let's put the baby equation, y equals parenthesis x plus 2, close parenthesis, square. So you see, the right parabola right in the middle is the parent one. And let's see from the parent one, what did we do to transform it to the baby picture there? Okay? So you see, we moved to the left. How many units? 1, 2, 2 units to reach the baby graph. So here the movement or the movement of the parent picture is called transformation, which is what your answer is. Okay? So your answer is left to move to the left 2 units. What makes it happen to move to the left 2 units? The change in the equation, add a number inside of x, make the change of your parent picture to move it to the left twice. Okay? So generally, if we add a number inside of the x, the transformation of the parent picture is moving to the left the number you have here, the number of units here. Okay? So second, here we still have the parent function y equals x squared, and this baby equation y equals x squared, the most basic part is still here, so you know it must be a U shape as its parent. But this time, we add a number outside of x. So this is inside x. Now the number is outside. Okay, so we add a number outside in the parent equation. So let's see the corresponding change or transformation on the parent graph. So let's graph both of the parent and baby equation to see the change on the graph. Okay. So I still use this parent equation. And this time the baby equation becomes x squared, then outside of it plus a 2. So you see, this is a parent equation going through the origin, and you moved it up. How many units? 1, 2. You move it up 2 units to reach the baby picture. So the transformation here is moving up 2 units from your parent graph. So what makes it moving up 2 units? You add a number outside of the x in your parent equation. So this kind of change in the equation is corresponding to this kind of the transformation on the graph. Okay? So we just add a number inside of the parent, inside of the x. It means move your parent to the left twice. Add a 2 outside of the x means move your parent picture up twice. Okay? So now let's look at an example. So here you have this baby equation, and you have to tell me what is the parent equation so that you can compare both of them. How can you tell me what is the parent equation? Look at your baby equation and look for the most basic part. So you can see the most basic part is x squared. So you know the parent equation is y equals x squared. Now you can put both the parent equation and the baby equation in the decimal calculator and look at the difference or the transformation on the graph. So let's put both of the equations in the calculator. I already have the parent equation there. And this time the baby equation is inside plus a number. So you'll see what? You see from your parent equation, go to reach your baby picture. You move to the left, how many units? 1, 2, 3, 4, 5. Move to the left 5. Why 5 units? Because you add a 5. Why moving to the left? Because you add a 5 inside of x. Add a number inside move means moving to the left. Okay? Next example. So here you see 2 numbers in the baby equation. It means we're going to have 2 changes in the parent picture. So let's look at them one by one. But before that, in order to compare the baby and the parent pictures, you have to look for what is the parent picture. So look at your baby equation. The most basic part is x squared. So your parent function here is y equals x squared. And you know the picture for both of them must be a U shape. So now let's compare both of these equations and look at the transformation on the graph. So this time the equation becomes x plus 3 plus 1 plus 3 inside and then plus 1 outside. So what is the transformation there? So from your parent, you're going to go to the left 1, 2, 3. Go to the left 3 units and then go up 1 unit to reach your baby picture. So the transformation here is going to the left 3 and then go up 1 unit. Okay. So your answer is move left 3 units and move up 1 unit. Because add a number inside means moving to the left, add a number outside means move up. Okay? So that's it about moving to the left and moving up by adding a number in the baby equation. Okay? So now let's look at the second 2 types of transformation. which is minus a number. And this time we're using y equals square root of x, the radical function, parent function, as an example. Okay? So your parent function look like this and your baby equation look like this, and this time the difference between these two equations is you subtract a number inside of x. Why inside? Because minus 2 is inside of the function square root here. Okay? So let's see what kind of transformation is going to happen on the parent graph. So let's put both of the equations in. So this time the parent equation becomes square root of x, and the baby equation becomes square root of x minus 2 inside. Okay? So here you can see the parent picture is on the origin, okay? And compared to the parent picture, our baby picture moves to where? Okay? From the parent to reach your baby picture, you're going to move to the right side. How many units? 1, 2, 2 units. Okay, so your transformation is moving to the right twice. What makes the parent picture moving to the right 2 units? You subtract a 2 inside of the x. Okay, so your answer would be move to the right 2 units. Okay. And now let's look at another type of transformation. So we still have this radical parent function, and this baby equation look like this. And this time the change in the equation is you minus a number again, but this time you minus a number outside of x. You minus 2 outside of the square root. So let's see what is going to happen if we minus a number outside. Okay. Let's put both of the equations in and compare their graphs. Okay. So the parent is still there, and the baby equation becomes outside minus a2. Okay. So you see, from my parent function go to reach your baby function, you're going to go down how many units? 2 units. Okay. So this is a transformation going down 2 units. Why going down 2 units? Because you minus a 2 and because you minus a 2 outside of x. So it means going down. Okay. So the answer is move down 2 units. Okay. So now let's do some examples. So here you have this baby equation, and you have to tell me what is the parent equation. So look at the most basic part of this baby equation. It is here, square root of x. So you know the parent equation is square root of x. And you know for both of the equations, because of the square root of x, the picture must be half of an arm. Okay? So now let's graph both of these equations and look for the transformation on the graph. So I have the parent function there, and the baby equation is minus 1 outside. Okay? So you see, from your parent picture here to reach your baby picture, you need to move down 1 unit. Okay? So our answer is transformation is moving down 1 unit. Why moving down 1 unit? Because you minus a number outside of the x. Okay. Next one. So here you have 2 numbers in the baby equation. It means you're going to have 2 transformations on the graph. So based on this baby equation, you are going to give me the parent equation, which is y equals what? So the most basic part in the baby equation is still the square root of x. So you know the parent function is y equals square root of x. So now put both of the equations in and look for the corresponding transformation on the graph. Baby one is minus 2 inside, minus 4 inside, and plus 2 outside. So you see what? You see from this parent function, you need to go up 1, 2, 2 units, and then go to the right 4 units. to reach your baby picture. So the transformation here is go up twice and then go to the right, okay? 4 units. Okay? Minus a number inside means go to the right, plus a number outside means go up. Okay? So the answer is move right 4 units and then move up 2 units. Okay, so now let's look at 2 examples. Oh, we already did it. So that's it about moving to the right or moving down. So if you subtract a number inside of the x, move to the right. If you subtract a number outside of x, move down. Okay? So now let's look at the last 3 types of transformation. And let's use absolute value of x as a parent equation this time. Okay? So we have the parent equation and the baby equation. And this time, the change in the parent equation is you have a number again. And this time, what is the relationship between the number and the x? You are not added, you are not subtracted. You are multiplying a number to your x. Okay? Generally, if you have a number in the front, the relationship is always multiplication, generally. Okay, so this time we multiply a number. What is this kind? We multiply a number. What kind of number? 2, right? 2 is bigger than 1. So we multiply a number bigger than 1. So let's see what kind of change on the graph is going to happen. So let's put both of the equations in the calculator. So this time we're using absolute value of x. And the baby function is 2 absolute value of x. You see what? You see this is your parent function. Some of you tell me, hey, both of the pictures are on the origin, so how do you decide which one is parent, which one is not? So look at your calculator here on the very left side. Yeah? So you see the parent function has the color red, and the baby function have the color blue. So you can see the difference between the colors. Yeah? And we see that the baby picture is not moving up, down, left, or right, but it becomes thinner. Okay? So you see the baby picture is thinner than your parent picture. So here the transformation is thinner. Okay? How do we describe thinner in mathematical ways? It is vertical stretch. Okay, so this is the vocabulary I'm looking for your answer transformation. So the transformation here is vertical stretch. So what would vertical stretch look like? So imagine this is a parent function. If you stretch it, if you pull it upward, so if you stretch it vertically, you pull it upward, you will make your parent picture thinner to become your baby picture. So this kind of action, pull it upward, it is called vertical stretch. And the result is make your parent function thinner. Okay? So what change in the equation can make your parent function thinner? You multiply a number in the front, and you multiply this number that is bigger than 1, such as 2. Okay? Next, the transformation. So here the parent is still absolute value of x, and the baby equation, this time we put a number in again, and we multiplied this number because it is in the front. And what is special about this number? It is 1/2. It is smaller than 1. So this time if we multiply a number less than 1, what will happen on the graph? So let's graph both of them. This time in the front we have multiplied 1/2. Okay? So you see The parent function is here, and the baby function is here. And what is the change this time? You make your parent function become wider. Okay, so how do we describe become wider in mathematical ways? It is vertical, again, vertical compression. Okay, so this is a vocabulary I'm looking for on the transformation part. So what vertical compression look like? Okay, so imagine you are press your parent function downward. You're pressing your parent function vertically downward. You will make your parent function wider, right? So this kind of action, press it down, is called vertical compression. Okay, and the result is to make your parent function become wider. Okay, so what kind of change in the equation will make the vertical compression happen? If you multiply a number smaller than 1 to your parent equation. And the corresponding transformation is vertical compression. Okay. Last type of transformation. Okay. Still our parent is absolute value equation and our baby equation. This time, what is the change in the baby equation? We multiplied a number again, but we multiply a negative number. So let's see, if we multiply a negative number, what is going to happen on the graph for the transformation? Okay. Let's put the parent and baby equations in, which is -3 this time. So you see what? You see this is the parent equation and your baby equation is here. So you see your baby function make your parent picture upside down. So the change here, the transformation here is upside down. Okay? So how do we describe upside down in mathematic way? Okay? It is reflection. And this is x-axis, and your parent function and baby function are reflection across x-axis, right? So this is reflection over x-axis. This is a word vocabulary to describe upside down. Okay, and what makes the upside down happen? If you multiply a negative number in the front. Okay. Some of you tell me, hey, I also see it is not only upside down, it also makes your parent function thinner. So my baby picture is thinner than the parent picture. Yes, it makes it thinner. So why? Because you multiplied a number bigger than 1. So here actually we have two transformations. One is reflection by multiplying a negative number. One is vertical stretch, make your parent thinner by multiplying a number bigger than 1. Okay. So let's look at an example. So here we have this baby equation. And you want to compare this baby equation with the parent equation. So you have to tell me what's the parent equation look like. Okay? So look at your baby equation and look for the most basic part. You see in the baby equation, the basic part is absolute value of x. So you know the parent function is absolute value of x, and you know the picture must be a V shape. Okay? So now let's graph both of them to compare. So I put both of the equations in, and you see compared to the parent equation, the baby picture is thinner than it. So I know to make it thinner, we need to vertical stretch. your parent picture. So the transformation here is vertical stretch. Okay? You stretch your parent picture. You pull it up to make it thinner. Okay? So what makes this happen? What makes the stretch happen? You multiply a number bigger than 1, such as 3. Okay? Next example. So in this baby equation, what kind of transformation happens on the parent picture? Okay? So first you have to look for the parent equation. It is y equals what? So look at your baby equation, and the most basic part, the most basic function is here, absolute value of x. So now we're going to put both of the equations in and graph them and look at the difference between them. Okay. So the baby equation becomes 1/3 and minus 2 outside. Let's see if this is right. Yes. Okay. So this time you'll see what? You see, compared to your parent function, your baby function is moving down. How many units? 2 units. And your baby function becomes wider by vertically compress your parent picture. So these are your two transformations. One is compression, one is going down twice. Multiply a number smaller than 1 means compression. Minus a number outside of x means moving down. And that's it. Okay. So far, we have finished learning all of the 6 types of transformations on your parent graph. But before that, let's look at one more example. Okay, I forget this one. Okay. So here you have this baby equation, and it's kind of special because you just have a negative sign in front. You don't see any numbers. So if you don't see any number, what number do you see? It means here. It means imaginary 1. So this time we times -1 in front of the parent equation. So let's see, the parent equation is still y equals absolute value of x. So let's graph both of them to see the transformation on the graph. Okay? So this time you have -1 times your parent equation. And you see, compared to your parent picture, your baby picture make it upside down. So upside down means the transformation is reflection. What makes the reflection happen? You multiplied a negative number in the equation. Okay, so this time you're not making your parent picture thinner or wider, okay? Because you multiply a 1. It is not bigger than 1 or smaller than 1. So the shape of your parent picture doesn't change at all. Okay. So far we have learned all of the 7 transformations on your parent picture. And if you add a number inside of x in your equation, you're going to move your parent picture to the left. If you add a number outside of the x, move up. Minus a number inside, move to the right. Minus a number outside, move down. Multiply a number bigger than 1, stretch. Multiply a number less than 1, compression. Multiply a negative number, reflection. Okay? So finally, let's do 2 examples. So here you have this baby equation, and you have to tell me what the parent equation is. Okay? So look at the most basic part in your baby equation. You have x, and the function here is square. So the most basic part is y equals x squared. Okay? And before we graph both of the equations and look at their transformation, let's not graph them first, because eventually our goal is if you look at the equation, look at the numbers, you can tell me the transformation on the graph instead of looking at the picture and tell me the transformation there. So let's look at them. Here you times a number in the front. It means the 2 means vertical stretch. Here you minus a 3 inside of x, inside of the parentheses. It means go into the right 3 times. Okay? And finally, you add a number outside of x, outside of the parentheses. It means go up 1 unit. So stretch right 3, up 1. Let's see if this is right by looking at the pictures. So now let's check our answer using the picture. Okay. So let's put the parent equation, which is y equals x squared. And let's put in the baby equation, which is y equals 2 parentheses x minus 3 parentheses square. Let me see the equation, plus 1. So let's see the changes. From your parent equation, you're going to move to the right. How many units? 1, 2, 3. Right 3. Okay? And then move up 1 unit to reach your baby equation, right? And you see what? You see the baby picture is thinner than the parent picture. It means what? It means you vertically stretched your parent equation. So here we have 3 transformations. Right 3, up 1, stretch, which is exactly what we just answered by just looking at the equation. Okay? 2 means stretch, minus 3 inside means going to the right, plus 1 outside means move up. It works for all kinds of 5 parent functions. Okay. Last example. Okay. So by looking at this baby equation, tell me what is the transformation on the graph. So before we're graphing them, let's look at the numbers and see if we can just answer it here. Okay. So in the front, you multiply a number. So what is this number? -1/2. It seems to be one number, but it has 2 parts. And each part is corresponding to a transformation. Okay. So multiply a negative number means reflection. Multiply a number smaller than 1 means compression. Minus a number outside of the house, outside of x, means going down 3 units because you multiply 3. Okay, so let's see if this is right. Reflection, compression, go down 3. Okay. So let's draw the parent equation and the baby equation. But before that, what is the parent equation? It is y equals what? Okay. So look at your baby equation here. What is the most basic part in it? It's here, square root of x. So your baby equation is, your parent equation is square root of x, and you know the picture must be half of an arm. So now let's graph both of them. So this time the parent equation is square root of x, and the baby equation is -1/2 square root of x, and the outside of it minus what? Let me see, -3. Okay, so let's look at it. From your parent equation, you need to go down 1, 2, 3 units to reach your baby picture. And you see what? You see your compared to your parent picture, your baby picture is making it upside down. which is reflection, right? And you see what? You see the curve, okay? So the parent equation have a more curving picture here, and your baby equation is more flat. What makes this happen? Imagine if you press your parent picture vertically here, you will make it less curving. Look like the baby picture. And if you reflect it upside down, it will exactly look what we have here for the baby picture. Okay, so here we have going down 3, reflection, and compression. Which is what we just answered by just looking at the equation, right? So negative number means reflection. A number smaller than 1 means compression. Minus a number outside means going down. Okay, so that's it about transformation from your parent function, parent picture to your baby picture based on the change in the baby equations.